1.1 Quadratic Functions. Here we're going to go over how to be able to read a graph and figure out those main points that we're going to need in order to be able to identify domain, range, whether you're looking at a maximum, minimum of a graph, and much more. Let's begin with interpreting a quadratic function. So, in this case, what we're looking at is a generic equation, a parabola. With that parabola, the equation is generally going to be the parent function of y is equal to x squared. This is just a generic parabola that would be facing upward. Now, the equation as a whole, once it's graphed, you can kind of see on the left-hand side that it says graph of y is equal to ax squared plus bx plus c. That would be our equation, okay? Now, using the graphs that we see on the right-hand side, we would be able to create that equation. Now, we're not at that point just yet. The most important thing that we need to pull out of this image is the fact that depending on where the parabola sits, it is going to tell you how many x-intercepts we are going to have. So notice, if our minimum of our parabola, and the minimum is the lowest point on the graph, is below the x-axis, we are going to have 2 points in which they would be our 2 x-intercepts. Now, if we take a look at the second graph, if our parabola hits the x-axis but does not cross it, we are only going to have 1 x-intercept. If our minimum is above the x-axis, we are not going to have an x-intercept. Remember, an x-intercept can only occur when the equation is equal to 0. So our y must be equal to 0. Okay? Now, as we were talking about maximums and minimums, our parabolas will always have a maximum or minimum. What we are looking for is either the lowest or the highest point of a parabola. Let's take a look at this first parabola. In this case, we have our parabola, which is facing up, and we know that those lines that are going up have arrows at the end of them, which means they continue to go up. In this case, it's not going to be a maximum. This would have a minimum. That minimum would be the lowest point on that parabola. As we take a look at the right-hand side, we can see that, once again, our parabola is facing down, which means it's going to continue going downward, which means we are going to have a maximum because that is the highest place that it will occur. Now, in most of these images, it might seem as though, oh, there's a random letter that's there. For example, these two up here. It says a is greater than 0 or a is less than 0. What it's referring to is our equation from slide 2, which said y is equal to ax squared plus bx plus c. So what this is telling us is that if a is greater than 0, meaning it is positive, it's going to face upward. If our a is less than 0, which means it's a negative, it is going to face downward. Now, these are the different parts of a quadratic function. So we're going to go over them little by little to just get a better understanding of everything that is going on. So the place in which we always take a look for a minimum or maximum is that highest or lowest point on the parabola. That is called your vertex. So the vertex would be located right here. In this case, at the bottom because it's facing upward. And that also gives us an idea to another important piece of information, which is the axis of symmetry. The axis of symmetry is basically a line, as you can see, that cuts the parabola in half to make it have a reflection on both sides of each other. Other important things that we can pull from this would be the x-intercepts. So let's take a closer look at this graph. If we had to give an answer for our vertex, we would go ahead and find that point right there, which would be 2, -2. And that would be our vertex. If they were to ask us for the axis of symmetry, the answer for would be where that line is created to give us that split of the parabola. In this case, it would be x is equal to 2. You have to provide the variable or the axis in which we're referencing. So if you just put 2, it would be a wrong answer because it's not saying whether it's on the x-axis or the y-axis. So it's extremely important that you be sure to put down these answers exactly as is being shown. Let's take a look at another key piece of information, our intercepts. An intercept is wherever we see that the line of our parabola is crossing the x-intercept. In this case, it is crossing at 2 different places. The x-intercept would be at 1, 0 and at 3, 0. What this tells us is that our equation that we originally started with is actually able to be determined if we work the problem backwards. So for example, what does that mean? That means that anytime if we have a point that says 1, 0, that means that in order to figure out if we get an answer of 1, we need something that will give us a 1 answer, which would be y minus. Now, let's try a different scenario for a different problem. Think of it as the same thing that we've been doing the majority of the summer, which is factoring. We're going to work a problem backwards. And we're going to say that ax squared, our generic formula, ax squared plus bx plus c. If I gave you a random equation like x squared plus 5x plus 6 and asked you to factor it, we would break it down into two possibilities. Either 1 and 6 or 2 and 3. This would be x and x, positive and positive. The only combination would be 2, 3. How do we get our intercepts? Well, our intercepts are always equal to 0. So what happens when we say x plus 2 equals 0? That means x is equal to negative 2. And when x plus 3 is equal to 0, that must mean x is equal to negative 3. What we see on this graph are the x-intercepts themselves. Meaning, if we are looking at 1, 0 and 3, 0, if we had to work the problem itself backwards, we would have to go and say, well, x is equal to 1 and x is equal to 3. And we're going to go in reverse. So we're going to start bringing the numbers over to the left-hand side. This means x minus 1 is equal to 0. X minus 3 is equal to 0. We're going to put these in parentheses. X minus 1 and x minus 3. Now we can actually FOIL these two parentheses. X and x is x squared minus 3x minus 1x plus 3. We combine our like terms. X squared minus 4x plus 3. For the problem that we were working on before, in that graph, this would be our equation. Are they asking for this problem itself to give you, or for you to give the equation? No. But this is a step in understanding how everything comes together. Slide 5. We're going to be talking about end behavior. Now, in end behavior, the most important thing that we're going to take a look at are these two statements that are down here. In order to understand what each one of these are referencing, we are going to go ahead and we are going to read them from left to right. Now, what does that mean? Generally, as we take a look at each one of these, we would start with the top one. And we would say, as x approaches infinity. As x approaches infinity. Another way of saying f of x is the same thing as saying y. Well, where is infinity? Infinity would be on the right-hand side. A negative infinity would be on the left-hand side for x. And when we're talking about y, our infinity would be on the top. Our negative infinity would be on the bottom. So all we're asking is when x is going towards infinity, which is to the right-hand side, where is that parabola showing? Notice this parabola, or that arrow, is going where? Towards positive infinity. And that's why it is written the way that it is down here. As we describe one side, we also have to describe the other. So we would write as x approaches negative infinity, meaning as we go left, where's it going? Well, it's also going up. So we're going to say f of x approaches positive infinity. The same thing would occur on the right-hand side. Now, the only difference between the left side and the right side would be the fact that as we are looking at our arrows, rather than them facing up, they're going to face down. So instead of x approaching infinity and f of x going towards a positive infinity, we see that these arrows are facing downward, which means instead of a positive infinity, we see negative infinities. If there is one thing that I can guarantee you, as long as you are dealing with a parabola, your y's, meaning your f of x, will always be the same. So notice on the left-hand side, if you have a positive a, right, which tells us whether it's going to be positive or negative, if it's facing up, it would have to go towards positive infinity on the y, on the f of x. If the leading coefficient, or our a, is negative, it's going to face downward, which means our f of x, when asking for the end behavior, is going to be a negative infinity. Our next part is going to be describing the increasing and decreasing. The easiest way to be able to do these problems is for you to always write down what is going on from left to right. And it is always from left to right, every single time. So, when we take a look at this first graph, are we going up or down with this first with this first parabola? We are actually going down. Where is it coming from? Well, it's coming from a negative infinity on the left-hand side, and it's approaching our axis of symmetry. We would say it's decreasing because the line is going downward. But with a parabola, one side goes down, and what happens? As we continue to move from left to right, then the right side would go up, and it would be an increasing. The order of it does not change. Anytime that it faces up, your left side will be decreasing, your right side will be increasing. When we are looking at a negative parabola, at that point, you will see that it will also always be the same, but our sides switch. Notice from left to right, on the left side, our line is increasing from left to right. So this would be increasing. As we pass that axis of symmetry, what happens? We're going to start coming back down, which means decreasing. You use the axis of symmetry, whatever that x value is, as the marker in which it starts or stops, depending on whether you're looking at the left or right-hand side. Something else to notice about increasing and decreasing is that you will always use parentheses. So notice, in each one of these interval notations, for infinities, whether they're positive or negative, it will always be a parentheses, but we are mainly looking at where there is a value, meaning that x. Notice they are all parentheses as well. Slide 7. Notice once again, read the graph from left to right. From left to right. And you're only going to use the x values in the interval notation. That is the only thing that matters, is our x itself. Let's take a look at slide 8. Now in slide 8, what we're going to do first, before anything else, is find all the easiest places that we are able to understand. First off, we know that our vertex is going to be -2, -4. That is our vertex. Now, our axis of symmetry is always going to be an x equals something number. And it is always the same as the vertex. We know that this parabola is a positive parabola, which means it faces upwards. Does this mean that we are dealing with a maximum or a minimum? Well, since it continues to move upward, that would mean this would be a minimum. Let's take a look at our increasing and decreasing. As we move from left to right, in both of those cases, what is going on from the furthest left to the furthest right? Well, we are going down, which means this is decreasing, and we are increasing towards the right-hand side. We know that the number that splits our increase and decrease is -2. I generally suggest that you go ahead and write down these answers from left to right so that there is zero confusion. So let's start off with decreasing. We are decreasing from -∞ to -2. And we're increasing from -2 to +∞. Let's take a look at our domain. What's another letter that can represent domain? That would be our x. Another letter that would represent our range would be our y, which would be our y-axis, right? With the domain, we're taking a look at what is the absolute minimum, what is the absolute maximum. Now remember, these arrows, this parabola continues to move leftward and rightward, which means that the domain would be from -∞ to +∞. Let's take a look at the y-axis, or our range. If you notice, it stops at -4, and as we're going upward, it goes to a +∞. So when we write this, this would be from the minimum, or the lowest point, which is -4, to a +∞. And the last part is our end behavior. This is basically what is going on with our x's and our f of x. So, as x approaches infinity, f of x approaches, now keep in mind, x approaching infinity means we're going to the right-hand side. What is going on as we move to the right? That line is going upward towards positive infinity. As x approaches negative infinity, f of x approaches positive infinity. Remember, just like we said before, our f of x are going to be the same because we are talking about a parabola. Let's take a look at slide 9. What I would suggest, go ahead, practice this one on your own. And whenever you need to, come back to the video and check the answer. So let's go over this video or this example as a whole. First thing we start off with is our vertex. Our vertex here is going to be -2, 4. Our axis of symmetry is -2. Here we're going to have a maximum because this is a negative parabola. It's facing down. We are increasing from left to right and decreasing on the right-hand side. So let's rewrite this. Increasing would be from negative infinity to -2, and decreasing would be -2 to positive infinity. Our domain would be from negative infinity to positive infinity, and this is not going to change whenever we are dealing with a parabola. Because notice, it will always move towards the right and it will always move towards the left-hand side. What will change is the range. In this case, it continues to extend downward, but when we are looking and following that parabola up, it stops at a maximum number of 4. This means that this would go from negative infinity to 4. Notice there is a bracket with the 4 because it is not an infinity. Anytime that we have a domain or a range and we are going up to that number, we are going to include it on the domain and range, which means we are going to use a bracket. Final step would be end behavior. As x approaches infinity, f of x approaches negative infinity. As x approaches negative infinity, f of x approaches negative infinity. Let's take a look at slide 10. Our vertex here would be 3, -2. Axis of symmetry would be 3. This would be a minimum. It decreases, then increases, which means our decreasing would be from negative infinity up to 3, and it's going to increase from 3 to positive infinity. Keep in mind, we are approaching that axis of symmetry, right? That is what splits the increasing and decreasing. So just by looking at what we've already completed, the axis of symmetry, or even the vertex, we can figure out where the increasing and decreasing would stop. Our domain is always going to be negative infinity to positive infinity. We take a look at the range, which means up and down. In this case, the lowest spot would be at -2, and it's going to continue to go up to positive infinity. Our end behavior as x approaches infinity, f of x approaches positive infinity, and as x approaches negative infinity, f of x approaches positive infinity. Slide 11. Now, this slide mainly goes over a couple of different things that we've learned in the past in different math classes, but is extremely important to help us figure out some of our answers that we would need. For example, whenever we have a standard form equation, which would be this middle equation itself, what ends up happening is we have ax squared plus bx plus c. In this case, the easiest way to find a y-intercept would be inserting 0 for x. When you do that, what are you left with? You're left with c. And that's the easiest way to figure it out. Now, when you are looking at intercept or factored form, right? F of x is equal to a times x minus p, x minus q. It's very easy to figure it out if it's already in factored form, because all it's going to be is the opposite of your p and q. So here we're looking at x minus p, x minus q. We're going to do the opposite of p, which would be, of a negative p, which would be a positive p, or a positive q. Now, what would happen if we went ahead and turned one of these positive? If it had positive p, now we're looking at a negative p. If we had a negative q, now we're looking at a positive q. And that is what's going to be used within our intercept. So we're doing the opposite of our P and Q. And lastly, if we're in vertex form, A times x minus h, close parentheses, squared plus k, your vertex will always be the h and k. This is extremely important that you be able to understand this, because you will be using this heavily within the chapters to come. If you have any questions, feel free to ask at any point.